friends, in this video we are discussing singular point and ordinary point. This topic we are chosen from the series solution or power series solution, because series solutions we will do about the ordinary point or singular point only. Series solution we will do about the ordinary point or singular point. So for that purpose only, first we are learning these two concepts. Okay, now what is mean by singular point or ordinary point means we have to consider the second order differential equation. Consider the second order differential equation is of the form a naught of x into dy by d square y by dx square plus a1 of x into dy by dx plus a2 of x into y is equal to 0. See here it is like a f of d into y is equal to 0 only. So ordinary differential equation of order 2 here. So we know that you will have the complementary function only. Solution y is equal to complementary function. Whenever the roots are repeated, roots are real and distinct, roots are complex, those are we are learned in previous lectures. Okay na, about first order differential equation. After that higher order differential equation we are learned this concept. But in this case we are discussing series solution. Series solution about singular point and ordinary point. Okay na. Now so consider the second order differential equation is of the form this one. Then a naught of x, a naught of x, here is a naught of x is what? The coefficient of y double dash. Now a point x naught is said to be, x naught is said to be ordinary point. Ordinary point if a naught of x naught is not is equal to 0. A naught of x naught is not is equal to 0. Then you can say this point is called ordinary point. If a naught of x naught is equal to 0, then you can say this is called singular point. A naught of x naught is equal to 0, then this point x naught point is said to be what? Singular point. That's it only. So what is the definition of singular point and ordinary point? Consider the second order differential equation is of the form a naught of x y double dash plus a1 of x into y dash plus a2 of x into y is equal to 0. Now we have to consider the a naught of x, the coefficient of the y double dash we are taking. If a naught of x is 0 at one point, that point is if I consider as a x naught, that is x is equal to x naught, then if it is 0, then you can say that x naught is called singular point. X naught is singular point. And if it is not is equal to 0, that is at x naught, a naught of x naught is not equal to 0, then you can say that is ordinary point. Okay na? Now singular point is only you have one type, but ordinary point we have two types. That is one second, this ordinary point you have another name, that is regular point also. Ordinary point or regular point. But the singular points we have two types, that is regular singular point and irregular singular point. Regular singular point and irregular singular point. So in this video we will discuss that regular singular point and irregular singular point also. Friends, regular singular point and irregular singular point, if you want to say, first this should be singular point. That x naught should be what here? X is equal to x naught is singular. If it is singular, then only you can classify that is a regular singular point or irregular singular point. If it is not a regular singular point, is nothing but what it is not a singular point, is nothing but obviously that is ordinary point. Okay na? So if x naught is a singular point, and that should be satisfy some condition. Which conditions now I will tell you. See, if the given equation we have to compare with the given differential equation, we have to compare with this. Later on what we have to do, you see, what is the quotient of y double dash here? A naught of x naught. So you have to divide entire differential equation with a naught of x. Then in this case you will have y double dash plus a1 of x into a1 of x by a naught of x into y dash plus a2 of x by a naught of x into y is equal to 0 by a naught of x is as it is only na. So this is just I am considering this a naught fraction is there na. Now this has plus p of x into y dash plus this is q of x into y is equal to 0. So here what is p of x is nothing but here a1 of x by a naught of x, and q of x is equal to a2 of x by a naught of x. Is it clear for everyone? You see, a1 by a naught is I consider as a p of x, and a2 by a naught is considered as a q of x. And here if a naught of x equal to 0 at x is equal to x naught, so this is called what? Singular point. So this singular point is said to be regular. When you can say regular is nothing but it should satisfy this condition. First condition, you see, if both x minus x naught into p of x, x minus x naught into p of x, and x minus x naught whole square into q of x. You see, x minus x naught into this p of x minus x naught whole square into this q of x are finite. In this case it is defined. Finite is nothing but my intention defined. Okay now, in this case you can say x is equal to x naught is called a singular point. Which type of singular point means? Regular singular point. Regular singular point. See, when you can say the given point is a regular singular point means first it should be a singular point. After that it should satisfy x minus x naught into p of x. Okay now, and x minus x naught whole square into q of x. These should be analytic at x is equal to x naught, or else simply what you can say means are defined. Nothing but those values you will get finite values. Okay now, then in that case this singular point is said to be regular singular point. Any one of them is failed case, then you can say nothing but otherwise x is equal to x naught is called irregular singular point. Irregular singular point. Is it clear for everyone? Which is a regular singular point and which is irregular singular point and ordinary point? I will repeat again. You see, first of all you have to consider the second order differential equation is of the form a naught of x into y double dash plus a1 of x into y dash plus a2 of x into y is equal to 0. Okay, if a naught of x is 0, what you have to do means a naught of x we have to equate to 0. If equated 0, you will get x is equal to some values na. Those points are said to be singular point, and where it is not is equal to 0, and those points are called ordinary point. Okay, this ordinary point, another name you have a regular point. Okay now, these ordinary point you have another name is regular point, but the singular points you have two types of singular points. Those are regular singular point and irregular singular point. Then how you can say the point is a regular singular point means first of all we have to compare the given differential equation with a naught of x into y double dash plus a1 of x into y dash plus a2 of x into y equal 0. Later on we have to divide with a naught of x. So a naught of x I have divided. Then you have to compare this one with p of x and q of x. Now we need to verify only one condition. That condition is x minus x naught into px and x minus x naught whole square into q of x, where x naught is what here? Singular point. Okay, now at x is equal to x naught you will get these all values. These two values will be finite. Then you can say that is analytic. So you can say that is a regular singular point. If you are getting infinite, that is nothing but not defined and not finite, then you can say directly that x is equal to x naught is called a irregular singular point. Okay, in the next video we will solve the problems on this topic. Okay, but for you I will solve one problem on this video. Later on I will solve more number of the problems in my next videos. Given problem is find ordinary and singular points of x into x plus 1 y double dash plus x square into y dash plus y is equal to 0. Okay, now we have to compare the given differential equation with a naught of x y double dash plus a1 of x y dash plus a2 of x into y is equal to 0. What is a naught of x is here? The coefficient of y double dash. Here what is a naught of x? That is x into x plus 1. Now you have to equate to 0. Then you will have x is equal to 0 comma x is equal to minus 1. So what you can say, at x is equal to 0 comma x is equal to minus 1 you are getting a naught of x is equal to 0. Therefore x is equal to 0 comma x is equal to minus 1 are called which points here? Ordinary point or singular point? Singular point. Remember, if determinant is equal to 0, then what you can say? That matrix is called singular matrix. So similarly here, whenever a naught of x naught is equal to 0, that point is said to be singular point. Okay now the remaining all other points are called ordinary points. So is x is equal to 2, x is equal to minus 3, x is equal to 5, all these are what here? Ordinary points or not? That's it. So is it clear for everyone? Right. In the next video we will solve the problems, verify the given point is a singular point or else classify the singular points. Okay.